Oh, sorry. Okay, I'm gonna do that later. All right. Do you understand English? All right. I'm going to carry on from where I stopped last time. So today, I'm going to continue with the equation of the tangent to a curve. All right. Now, I just want to remind all of you that we are close to the end of the topic. It's not very long. It's one of the shortest in grade 12. Today I have to introduce one last aspect and then we are done. All right. Okay, so in this question here, I took the question from Mind Action series. Right? The question says, find the equation of tangents to a circle with that equation. Okay, so the equation of the circle is that one there. You need to find the equations of tangent to circles which are parallel to the y-axis. Okay? Now, if you are to determine the equations of tangents that are parallel to the y-axis, you need to know that the y-axis does not have a gradient. The gradient of the y-axis is undefined. Alright? All vertical lines have no gradient. Their gradients are undefined. All horizontal lines have a gradient that's equal to 0. Okay? So the y-axis, okay, has got a gradient which is equal to that which is undefined. So if I draw a circle based on the coordinates of the center, if I draw a circle such that the center is in the fourth quadrant, right? Because x at the center is positive 2 and y at the center is minus 3, which means the center must be in the fourth quadrant, right? Now, whenever you're answering analytical geometry questions, it's always wise to visualize it. So sometimes you may need to draw a sketch. Can I have your attention, please? Can I have your attention? Right? So I drew the circle with the center that's in the fourth quadrant. Then, if you want to carry on here, you need to be aware that we can draw a tangent at this point here. That will look like that. We can also draw another tangent on the other side of the circumference, and that tangent is going to look like that. Which means we can draw two tangents to this circle, and those two tangents will be parallel to the y-axis. Therefore, if we want to find the equations of the two tangents, we substitute the value here of y. Okay, the value of y here is going to be a common value for both of them. And that value is going to be the value of y at this point here. I'm going to repeat what I'm saying. We have got a circle, the center is in the fourth quadrant. Okay? We need to determine the equations of tangents that are parallel to the y-axis. So those two tangents are going to be this one here and that one. Fortunately, we know that from this point here up to this tangent, okay, the value of y here is the same as the value of y there. The value of y here is the same as the value of y there. So the value of y at the center is the same as the value of y at the point of contact. Because a tangent is perpendicular to a radius. or a tangent is perpendicular to a diameter. So, if we want to solve here for x, okay, we have to find x because if the line is a vertical line, the equation will be of the form x equal to something. I hope you remember that you have done this before in grade 9, grade 10. If a straight line is vertical, its equation will be x equal to something because there is no gradient. So you won't have the m. Remember, the equation is y equal to mx plus c. If this m here is undefined, it means the equation will be x equal to something. So we need to find that value of x that's here and that value of x that's there. Okay? Well, okay. Let me be honest with you. This question is not a level 1 or 2 question. Okay? It's not a level 1 or 2. Right? It's not level 1 or 2. Right? So, I'm going to repeat this for the last time. Hey, can you stop that, please? Stop it. Not to answer the phone. Alright. The y-axis. The person who is calling you, that I would doubt whether they really care about you. You must tell your dad that you are doing maths at this time. He knows that. Okay. Why would he call you whilst you are in the lesson? No. There's nothing like that. Alright. Let me carry on. Alright, can I listen? Can you do me a favor, please? I need your maximum attention. For you to be able to understand what I'm talking about, I need your maximum attention. Yes. Okay. All right. All right. Let me do what you have requested. Thank you, Captain. I'm very happy if Elena is asking. I get very happy. Okay. I get very happy. Do you want me to jump? All right. Okay. All right. The question says, find the equations. This is plural. Okay. Find the equations, okay, of the tangents to that equation of a circle, right, such that or which are, number 1, for A, it says parallel to the y-axis. Now, I want you to be aware that you also have to use your common sense to do the question, right? So, we draw a Cartesian plane to visualize what's happening, okay? Why am I drawing the Cartesian plane? To visualize what the question wants. Okay? This question here is not a direct question, so it requires you to understand what it wants. So, we know that the gradient of the y-axis is undefined. And that's not grade 12. It's grade 9, grade 10. Okay? Remember, I've been telling you since I started the topic last week and before I started. Refresh yourself, go over your grade 11 work. And I even send you those e-books. Okay? So you should have gone over your parallel lines, your perpendicular lines, and so on. So if the tangent is parallel to the y-axis, it means that tangent does not have a gradient. Remember, if two lines are parallel, their gradients are what? Are equal. Remember that. You were taught that in grade 9 and grade 10. Okay? So, I don't understand why someone would behave like they've never heard about it. You have. Right, listen. So, if the gradient of the y-axis is undefined and the tangent is parallel to it, means the gradient of that tangent is also undefined. Okay? So let's visualize by drawing a sketch. So we are in the fourth quadrant. Why? Because the center of this equation here, of that circle, is at x equal to 2 and y equal to minus 3. At this stage, I expect you to know how to determine the center of a circle if the equation is written in that form. So the center is at x equal to 2 and y equal to minus 2. Now, that point will be in the fourth quadrant. Because it's only in the fourth quadrant where x is positive and y is negative. You should also know that, and that's grade 9, 10, and 11. Okay? Then, if the center is here, I can draw a circle. Let me just draw a sketch of that circle. It probably looks like that. Okay? I'm drawing a sketch that it can help me to understand what's going on. Alright? Then the question says, we need to determine the equation of tangents that are parallel to the y-axis, which means I can draw the tangent from this point and another tangent from that point. It means we have two tangents on both sides of the circumference. And both of them, they are parallel to the y-axis, like this. So this is parallel to that one, they're also parallel. So all three are parallel to each other. So we need to find the equation of this tangent, the equation of that tangent. Two equations. And both equations don't have m, that is the gradient. So how do we carry on? The good thing is we know that the value of x here is 2. The value of y is minus 3. Because a tangent and a radius, or a tangent and a diameter, they intersect at a common point there. It means if the diameter is perpendicular to the tangent, means the value of y and x here is the same. So the value of y rather is the same as here. The value of y, not x. X is not the same because the value of x here is the same as there. If this was, say, a radius. Okay? The diameter is perpendicular to a tangent. From your grade 11 circle geometry. If the radius is perpendicular to the tangent, it also means that the diameter is perpendicular to the tangent. Okay? Therefore, all I have to do is substitute the value of y at this point here, which is minus 3, and also substitute the same value of y there into the equation of the circle. Why do I have to do that? To eliminate y so that I can solve for what? For x. So, where there is y here, I'll put negative 3. Because the point of contact is a common point for both the tangent and the circle. Okay? The point of contact is a common point for both the tangent and the circle. Therefore, y is equal to minus 3 at both points where the tangents intersect with the circle. So, I put y equal to minus 3. As you can see here, I'll get 0. So I'll end up having x minus 2 all squared equal to 16. The objective is to solve for x, to find x here and to find x there. Okay? One of the values of x will be negative, the other one will be positive. Then you take square root both sides, that's not grade 12, and then you get that. So we are here. Alright? Then find the square root here, it will be x minus 2. On the right, it becomes plus or minus 4. Then, you simplify, you get x equal to 6 and x equal to minus 2. These two are our two equations of the tangents. Okay? They are our two equations of the tangents. Yeah. Let me warn you. You saw what I wrote here, it's still there, I didn't erase it. If you have got problems in analytical geometry, the chances of you passing maths are very slim. I'm going to say this, passing with a good mark, they're going to be very slim. Because Your maths paper 2, it starts with the stats, and the stats is not like that easy. From my experience, some learners they've got issues with the terminology in statistics and so on, and the grade 12 regression. So you start with the first question on stats. Your next 2 questions are going to be on analytical geometry. If you don't know your analytical geometry, by the time you get to trig, you are finished. And then the geometry is that dead. Can you put your phone away, please? Put your phone away. You know what? I wonder why you like to play with the phone during a math lesson. What gives you the guts to do that? All right. Let me carry on. Can you put it away, please? All right. I'm going to carry on to the next one. Now, the next question, the same concept that I used to do this one here applies to 2B. The only difference is that in 2A, we're dealing with lines that are parallel. In 2B, the lines are horizontal, and they will be parallel to each other as well. So the gradient of the x-axis is 0, because it's a horizontal line. All horizontal lines with a gradient that's equal to 0. So we need to find equations of tangents such that the tangent is drawn at this point, another one drawn at that point, and they are parallel to the x-axis like this. So they are both parallel to the x-axis. Okay? So we need to find the value of x of y here. Please, it's no longer x now, it's y, because the equation of the horizontal line starts with y equal to, right? So I need to find the value of y here and the value of y there. To do that, I have to substitute the value of x here. The value of x here is a what? It's a 2. So the value of x there is a 2. The value of x at the other end there is also a 2. So I have to substitute that x equal to 2 into this equation. If I put 2 here, 2 minus 2 gives me 0, so I'm left with an equation in terms of y. Right? So that's what I'm going to do. So on the next page, I wrote my equation first, then I substituted x equal to 2, okay, to eliminate the x in that whole equation, so I was left with y only. Then I got that, used my knowledge of equation from grade 11, found the square root on both sides, then simplified until I got y equal to 1 and y equal to -7. So these are the 2 equations of the tangents. The gradient is 0. So this equation y equal to mx plus c, if the gradient is 0, means your equation will be y equal to c. Okay? So that's what we have there. It's not the time to do it. No, there's nothing like that. There's nothing like that. That's why you have a weekend, you need to use your time wisely. Alright. Can I carry on? we're starting to get now. All right. So this is the situation with that question.